Good day, viewers. What we are going to be doing today is on probability, and we are going to be focusing on multiplication law or combined events of a probability. We can recall that a probability is an event happening over a given numeric value of number. What I'm trying to say is that, take for instance, you are told to find the probability of a number of a particular event happening over a certain given number of that event. Take for instance, you have x, that's the probability, which is the same thing as the probability of event happening is equals to x, which is equals to the number of times, number of require events. That means the question that we are trying to look for, or the particular probability we are trying to look for outcome over the total number or number of possible outcomes. We should also recall that the probability that that particular thing will not happen, will not happen, is the same thing as saying 1 minus x. That means the probability of it happen is x, not happening is nx. If you add the two together, it will give you 1. So if you now want to find nx, that means the probability of it not happen, n is equals to 1 minus x. And that's what we've just written up here. So what about if the probability is x is equals to 1? That means this probability of the event happening is equals to 1. That means it is certain that it will happen. That means it is certain that it will happen. What about if you have x is equals to 0? That means it is not going to happen. It is certain that it is not going to happen. Not going to happen. So now, if you are now told to find, and also note that all this take place between 0 is less than x, less than 1. That means it can either be 0, not happen, it's not going to happen, x, the probability it will happen over not happen, and 1, the probability is certain that it will happen. So you should bear this at the back of your mind. Now, when we are now saying that, we want to do want to find the combined event, whether it will happen, what we need to do is we're going to apply set rules in this nature, and then this nature of probability, and it can either be inclusive or exclusive. I will explain what I mean by that very soon. We're going to apply set rules or Boolean rules. If a computer person, they will call it Boolean rules. And what this means is that if an event ABC, you have A B, C are mutually exclusive, that means, what I mean by mutually exclusive is that if these events happen, or event B can happen, or event C can happen, then we call it, that means event A, probability that the event A happen, or probability that event B happen, or probability that event C is happening. We're going to have it as P over A. That means event A plus event P, B plus event C. That means you have to find the probability of this A. You now add it to probability of B and probability of C. That is when they are exclusively happening. I mean, that means that the probability is going to happen, or this is going to happen, or this is going to happen. And you want to take it at the same time. You call it's mutually exclusive. But now, I'm just trying to do a recap on all the things we've talked about before. But when you have probability of event A happening and probability of event B happening, can you see that I'm using and? Or probability of event C happening, we'll say they are independent of each other. If events A, B, C are independent, and that the probability of A happening and probability of B happening and probability of C happening. Then to find the total probability is going to be PA plus, multiply by, sorry, I need to clean that up. PA multiplied by PB multiplied by PC. That's going to be the total probability of this particular event, these three events happening at the same time. So this will help you also, and this is what we're actually talking about. This is the combined events probability. Combined event probability. That means the three are happening at the same time. So I'm now going to be using an example to explain what we've just talked about now. Okay, shortly we're going to be looking at this small example to be able to clarify what multiplication, probability law under multiplication means. Okay, so this is a Whitehead question. It says you're given a particular table, show the number of limes and apples of the same size in a bag. This particular table, shows the number of limes and apples in a sample in the same size in a bag. If two of the fruits are picked at random, one at a time without replacement, I think you should just, when you see this particular question, this kind of question in your work, you should just underline a time without replacement. Find the probability that both are good limes. Now, this is a lime, this is the lime, this is good. This is what they are talking about. This is what they want you to lay emphasis on. Now, both are good limes. Number one thing you need to do is you have to find the number of lime. You have to find the number of apple in that same bag. And we know this is a good one, this is the bad one, this is a good one, this is the bad one. So the total number of apples and limes in that bag is this plus this plus this plus this. So total number, that's the total outcome. Total number of apples and lime is equals to 10 plus 8 plus 6 plus 6, which is going to give you 30. Now, we now want to find the probability that we have lime, both are good limes. They are both good limes. That means, and you're told that they are random, you chose two things at random. The two of the fruits are chosen, are picked at random. So that means, and it's not being replaced back. So what you need to do is just write lime good is going to be, what's the total number of good limes? We have 10. What's the total number of outcome? We have 30. As for the first one, the second one is going to be probability that it's also good lime that is being chosen the second time is picked. Is going to be, now remember that we've chosen 1. That means this is going to reduce by 1. And this is also going to be reducing by 1. The good ones is reduced by 1. And the total is also reduced by 1. So we're going to be having 9 over 29. So what's the probability that we have both are good limes? PR LG1 plus. Now, we are not going to be, why do we need to use plus or minus? Because both are good limes. That means at the same time they want you to find out what their probability are when two are chosen at the same time. Then PRLG1 lime good 2 is going to be 10 over 30 times 9 over 29. This is going to give you 3 over 29. The first one is going to be 3 over 29. Now, both are bad fruits. When they are both bad fruits, so to find out if the probability of it when both are bad, what we need to do first is to understand the question very well. We need to understand the question very well. At the point in which we are asking for both are bad fruits, that means both lime and both lime and the apple, they are both bad fruits. That's what that's what the question is asking us. Then we should now find the probability. And for us to find the probability, this is bad, this is lime, this is apple, this is apple. So if both are bad fruits, then the total number of bad fruits, is going to be 6 plus 6, which is equals to 12. Then the first bad fruit probability is going to be 12 over 30. The second bad fruit is going to be 11 over 29. So if both of them are bad fruit, that means we are going to be doing a multiplication at the same time. So both of them are bad fruit is going to be bad fruit 1 multiplied by bad fruit 2, because they are both chosen at the same time. So we're going to be having 12 over 30 multiplied by 11 over 29, and that should give us 22 over 145. The third question, which is one is a good fruit and one is a good apple and other is a bad lime. This is clearly, and this is straightforward, because we're just going to be applying the same principle we use at the first initial two questions that we were asked to solve. Now, both of them are good lime. I mean, one is a good apple. The total number, we can record that the total number of apple is probability is a good apple, which is the first probability, is going to be giving us 8 over 30. We should record that the total number of fruit is 30 here. Then the second one, which is probability is a bad lime, which is the second one. Now remember that both of them they have reduced the number, but the bad lime is still 6, and over the total number is now going to be 29, because one has already been taken, but one probability has already been taken, so it's going to be 29. So the probability of them taking at the same time, which is 2 are selected at the same time, is going to be P over GA1 over multiplied by P over BL2, which is going to be 8 over 30 multiplied by 6 over 29. And this is going to give us 16 over 145. Now remember, there are two questions at the same time. One is a good apple and remember we have one and before, and other is a bad apple. Then we'll now multiply this by 2, and that will give us the answer. I mean, we'll multiply this by 2. That will give us this answer. We can see clearly that probability is very straightforward, but we just have to understand the language that is being used on each question. Thank you very much.